Now when theta equals 0, the acceleration is positive, 7/5 omega squared r. We can get that in terms of omega squared if we plug in for r. So we have to use the SI unit for r. We need r in meters if we want our acceleration to be in meters squared per second. So we plug 0.15 in here to get 0.21 omega squared. So what does a positive acceleration mean? So at theta equals 0, okay, the piston is moving to the right and speeding up. If we take directions to the right as being positive for this piston. But it could also be moving to the left and slowing down, because directions to the left are negative. If the piston is slowing down in the negative direction, we say its acceleration is also positive. So that happens when theta is 0. So that's what the stationary values for the maximum, for the acceleration, sorry. Here are two other stationary values. Both of these are negative. So for the values of theta that give these accelerations, the piston is either moving to the right and slowing down, or it's moving to the left and speeding up. These values for the accelerations occur for values of theta that give cos theta equals -5/8. Now there are two values of theta that give each of these accelerations. One of those two values is 128.68 degrees. Now to get the other value of theta, we just reflect this angle through the x-axis here. So we have this angle here, an angle between 180 and 270 degrees. So this is the t quadrant. Only the tan function is positive for angles in this quadrant. So the cos function is negative. So if you reflect this angle through, just get this angle here and add it onto 180, you get 231.32 degrees. So these are the two values of theta that give cos theta equals -5/8. Anyway, for those two values of theta, we get two negative accelerations. This acceleration here has a greater magnitude than this acceleration here. So this is the minimum. This is the greatest negative acceleration.